ਇੰਟਰੋਡਕਸ਼ਨ। ਵਿਦਿਆਰਥੀਓ, ਤੁਹਾਡਾ ਅੱਜ ਦੀ ਕਲਾਸ ਵਿੱਚ ਸਵਾਗਤ ਹੈ ਜੋ ਕਿ एरेन्स ਬਾਰੇ ਹੈ। Alkyl and aryl substituted benzene derivatives are called ARENES। ਕੀ ਤੁਸੀਂ ਜਾਣਦੇ ਹੋ ਕਿ एरेन्स एरोमेटिक हाइड्रोकार्बन्स ਹਨ ਜਿਨ੍ਹਾਂ ਵਿੱਚ ਬੈਂਜ਼ੀਨ ਰਿੰਗ ਹੁੰਦਾ ਹੈ, ਜਿਵੇਂ ਕਿ ਬੈਂਜ਼ੀਨ ਅਤੇ ਮਿਥਾइल benzene। The term aromatic originally referred to their pleasant smells, but now implies a particular sort of delocalized bonding। पर इस संबंधी होर पढ़न तो पहला आओ आज दी क्लास दे learning objectives जान लइए।
Upon completion of this topic, the learner will be able to define and classify arenes, discuss methods of preparation of arenes, discuss physical and chemical properties of arenes, discuss isomerism in arenes.
Aromatic compounds are of two types, benzenoids and non-benzenoids. Benzenoids are those containing one or more benzene rings. Non-benzenoids are those without benzene ring. Let us first try to understand what aromatic compounds are. Aromatic compounds. These are the cyclic unsaturated compounds which are highly resonance stabilized and are relatively more stable than their open chain counterparts or isomers. Children, for any compound to be classified as aromatic, it must fulfill two criteria. First, it must have an uninterrupted cyclic cloud of pi electrons above and below the plane of the molecule. For this, molecule has to be cyclic and each atom in the ring must have an unhybridized p orbital to form pi electron cloud. Similarly, for the formation of pi cloud, p orbitals must be able to overlap, and for overlapping of p orbitals, molecule has to be planar. Or, in the other words, for a molecule to be aromatic, the first required condition is that molecule has to be cyclic with at least one or more double bonds in the ring and planar in structure and must be capable of exhibiting resonance. Children, do you know that according to Huckel's rule, for any cyclic planar compound to be aromatic, it must have a pi electron cloud of 4n plus 2 delocalized pi electrons. By this definition, the simplest aromatic species is cyclopropenyl cation, represented as shown on the screen. Similarly, benzene, naphthalene, anthracene are all aromatic in nature. Certain heterocyclic compounds such as pyrrole, furan, thiophene and pyridine are all aromatic in nature.
विद्यार्थियों, आओ हुण anti-aromatic compounds बारे जानिए। These are cyclic compounds containing delocalized electrons whose stability is lesser than their open chain counterparts. These contain 4n delocalized pi electrons. For example, cyclobutadiene, cyclooctatetraene. आओ हुण non-aromatic compounds बारे जानिए। These are cyclic compounds which do not have continuous ring of overlapping p orbitals and may be non-planar. विद्यार्थियों, आओ हुण बेंजीन बारे जानिए। It is an aromatic hydrocarbon having molecular formula C6H6. Benzene was recognized as the first aromatic hydrocarbon, with the nature of its bonding first being recognized by Frederick August Kekule von Stradonitz in the 19th century. Every carbon atom of this molecule is sp2 hybridized. It has delocalized pi electron cloud of 6 pi electrons 3 pi electrons lying above and 3 pi electrons lying below the plane of the molecule. The structure is also illustrated as a circle inside the ring to show 6 electrons floating around in delocalized molecular orbitals. This also represents the equivalent nature of 6 carbon-carbon bonds, all of bond order approximately 1.5. This equivalency is well explained by resonance forms. The electrons are visualized as floating above and below the ring with the electromagnetic fields they generate acting to keep the ring flat. The circle symbol for aromaticity was introduced by Sir Robert Robinson in 1925. It has two important equivalent canonical or resonating forms as shown on the screen. Due to resonance in this molecule, every carbon-carbon and carbon-hydrogen bond is equivalent. It gives only one mono-substitution and two di-substitution products.
Isomerism in arenes. Substituted arenes show either positional and chain isomerism. Let us summarize some observations regarding the isomerism shown by the substituted arenes. Mono-substituted arenes. Isomerism is not shown by mono-substituted benzene having methyl or ethyl group as the side chain because all the positions on benzene ring are identical. However, mono-substituted benzene with a side chain consisting of 3 or more carbon atoms show chain isomerism. For instance, the compounds shown on screen are chain isomers. Mono-substituted polycyclic arenes exhibit positional isomerism. For example, methyl naphthalene exists in two isomeric forms, that is, 1-methyl naphthalene and 2-methyl naphthalene. In case of polycyclic compounds containing more benzene rings fused together, the number of positional isomers also increases. These can be shown as the two structures shown on the screen. Di-substituted arenes. The various positions in mono-substituted derivatives are not equivalent with respect to the position already occupied by the substituent. For example, by taking the position of the substituent as number 1, other positions are as shown on screen. A close look at the structure reveals that position 2 and 6 are equivalent and are called as ortho with respect to position 1. Position 3 and 5 are equivalent and are called as meta with respect to position 1. Position 4 is called as para with respect to position 1. Di-substituted benzenes and higher arenes show positional isomerism. This takes place due to the presence of a substituent at different positions in the benzene ring. For example, in case of dimethyl benzene, commonly called as xylene, has 3 positional isomers. The 3 isomers of xylene are shown on the screen: orthoxylene, metaxylene and paraxylene. The melting point of orthoxylene is minus 28 degrees centigrade. Its boiling point is 144 degrees centigrade. In case of metaxylene, the melting point is minus 54 degrees centigrade and the boiling point is 139 degrees centigrade. Paraxylene has melting point of 13 degrees centigrade and boiling point of 138 degrees centigrade. Besides the 3 possible dimethyl benzenes, a 4th isomer, ethyl benzene, is also known. It has a melting point of minus 95 degrees centigrade and boiling point of 136 degree centigrade। विद्यार्थियों, आओ हुण preparation of benzene बारे पढ़िए। The first method which we will learn is by decarboxylation of sodium benzoate. We will learn about the laboratory method. Benzene is formed on dry distillation of sodium benzoate with soda lime. Have a look at the equation on the screen. The second method of preparation of benzene includes reduction of phenol. Benzene is obtained by dry distillation of phenol in the presence of zinc dust. Zinc oxide is collected as byproduct in this reaction. We will next learn about preparation of benzene by reduction of phenol by Fischer method. In this method, phenol reacts with hydrogen in presence of molybdenum trioxide to form benzene and water. We will next learn about preparation of benzene by hydrolysis of benzene sulphonic acid. As you see on the screen, benzene sulphonic acid on hydrolysis with steam in presence of dilute hydrochloric acid gives benzene along with sulfuric acid. We now come to the next method of preparation of benzene by reduction of benzene diazonium chloride. Hypophosphorus acid, that is H3PO2, can be used for reduction of benzene diazonium chloride to get benzene. Benzene diazonium chloride reacts with hypophosphorus acid and water to form benzene, phosphorus acid, nitrogen and hydrochloric acid. We will next learn about preparation of benzene by hydrolysis of phenyl magnesium bromide. Phenyl magnesium bromide, which can also be called as Grignard's reagent, gets hydrolyzed with water and form benzene and magnesium salt. One more method of preparation of benzene is by reduction of chlorobenzene. Chlorobenzene gets reduced to form benzene when it reacts with sodium hydroxide and nascent hydrogen in presence of nickel and aluminium. Next method of preparation of benzene is by trimerization of acetylene. 3 molecules of acetylene or ethane trimerization in hot copper tubes to form benzene, which is shown in the form of equation on the screen. The next method of preparation of benzene is by hydroforming of n-Hexane. As you see on the screen, n-Hexane reacts with heavy metal oxides at 500 degrees centigrade to form benzene and hydrogen. विद्यार्थियों, ਹੁਣ तक ਅਸੀਂ aromatic compounds ਦੀ ਬਣਤਰ ਅਤੇ ਉਹਨਾਂ ਦੀ preparation ਬਾਰੇ ਕਾਫੀ ਕੁਝ ਜਾਣ ਗਏ ਹਾਂ। ਆਓ ਹੁਣ ਇਹਨਾਂ ਦੀਆਂ physical properties ਬਾਰੇ ਪੜ੍ਹੀਏ। Benzene is a colorless liquid at room temperature. It has a characteristic smell. Its boiling point is 80 degrees centigrade. It forms a colorless crystalline solid on cooling. The melting point of crystalline solid benzene is 5.4 degrees centigrade. It burns with smoky or sooty flame. It is lighter than water and is immiscible with water. Being nonpolar in nature, it is miscible with many organic solvents like alcohol ether, acetone, acetic acid, carbon tetrachloride, carbon disulfide, etc. It is carcinogenic in nature. ਹੁਣ ਅਸੀਂ chemical properties of benzene ਤੇ ਧਿਆਨ ਕੇਂਦਰਿਤ ਕਰਾਂਗੇ। It is expected to be highly reactive in nature due to presence of 3 weak pi bonds in the ring. But it is highly unreactive in nature as the pi electrons of this molecule are in conjugation and thus it is resonance stabilized. Therefore, it does not show properties similar to that of unsaturated hydrocarbons such as alkenes and alkynes. Mainly, it is known to undergo substitution reactions. It shows the three types of reactions: addition, electrophilic substitution, and oxidation. Let us discuss them one by one. Firstly, we will take addition reactions of benzene. In this, let us take up hydrogenation, reactions which occur in different ways. To begin with, we will take up catalytic hydrogenation. What does the name suggest? I'm sure you'll all agree that hydrogenation reaction takes place in presence of a catalyst. In the presence of catalysts like nickel, platinum or palladium, benzene can be hydrogenated to cyclohexane as shown on the screen. The next method is reduction with hydrogen iodide. Reduction with HI. Benzene, on heating with concentrated hydrogen iodide at 250 degrees centigrade, undergoes complete reduction to form cyclohexane. The third method about which we will learn is Birch reduction. When benzene in ethanolic solution is reacted with sodium and liquid ammonia, then 1,4-cyclohexadiene is formed. This partial reduction of benzene is called Birch reduction or Birch reaction. We will now learn about the next type of reactions, that is addition reactions of benzene. First, in this category, we will discuss about halogenation reactions. In the presence of sunlight, benzene can be halogenated to form hexachlorobenzene. Benzene hexachloride is also known by many other names. Example, BHC, gamhexane, gamane, lindane 666 and 1,2,3,4,5,6 hexachlorocyclohexane. It is a very strong insecticide and pesticide.
आओ हुन इलेक्ट्रोफिलिक सब्स्टिट्यूशन रिएक्शंस ऑफ बेंजीन बारे जानिए. Benzene ring is a source of electrons as it has pi electron cloud of 6p electrons lying above and below the plane of the molecule. Any electron seeking reagent that is an electrophile can cause substitution of hydrogen ion from any carbon atom of the ring to form substitution product. Let us have a look at the general mechanism of electrophilic substitution shown on the screen. The electrophile, that is E positive, attracts on the electrophilic center generated on the benzene ring as shown on the screen. The arenium cation loses the hydrogen ion to attain its aromatic character. This also results in the formation of substituted product.
Let us list different electrophilic substitutions of benzene ring. Halogenation. Haloarenes are obtained when benzene is treated with halogens in the presence of halogen carrier such as FeX3. The attacking electrophile in this reaction is halonium cation, that is X positive ions, which is generated by the reaction between the ferric halide and halogen as shown in the reaction. Instead of ferric halide, we can also use aluminium chloride, that is AlCl3. These two, that is FeX3 and AlCl3, are also called as halogen carriers. We see on the screen that FeX3 reacts with X2 to give FeX4 negative plus X positive. Benzene reacts with X2 in presence of FeX3 to form haloarene and HX.
Children, let us now discuss the mechanism of chlorination of benzene. The mechanism is illustrated by the chlorination of benzene carried in the presence of Lewis acid, catalyst, ferric chloride or FeCl3. Let us discuss the various steps one by one. Let us discuss the step 1 first. Generation of electrophile, that is, formation of chloronium ion. Let us discuss the step 2. The second step includes attack of electrophile on the ring. The electrophile attacks the ring to form carbocation intermediate which gets resonance stabilized. We will now discuss the third step, which is abstraction of hydrogen ion by the nucleophile. The hybrid loses a hydrogen ion to the nucleophile FeCl4 negative in a fast step. Order of reactivity of halogens is as shown on the screen. Fluorine is more reactive than chlorine, which in turn is more reactive than bromine, which is more reactive than iodine. Iodination of benzene is reversible in nature, and in order to get good yield of iodobenzene, strong oxidizing agents such as nitric acid or iodic acid, that is HiO3, are to be used, which oxidizes hydrogen iodide back to water and iodine.
We will next learn about the second method, that is nitration. Nitrobenzene is obtained when benzene is treated with a nitrating mixture of nitric acid and sulfuric acid. The attacking electrophile in this reaction is nitronium ion, that is NO2+, which is generated with the reaction between concentrated sulfuric acid and nitric acid.
Let us now learn about the mechanism of nitration of benzene. Nitration of benzene is carried by the nitrating mixture of concentrated nitric acid and sulfuric acid. Let us have a look at the different steps involved in the reaction. Step 1 is generation of nitronium ion as an electrophile. We will now discuss about step 2, which is attack of the electrophile on the ring. The electrophile attacks the ring to form carbocation in a slow step. The ion gets stabilized due to resonance. Have a look at the process on the screen. Children, let us now have a look at the third step, which is abstraction of hydrogen ion by the nucleophile. The nucleophile in this case is HSO4 negative ion, which readily abstracts a hydrogen ion in a fast step to form the desired product, that is nitrobenzene.
We will next learn about sulphonation reactions of benzene. Sulphonic acid is obtained when benzene is treated with concentrated sulfuric acid. The reaction is highly reversible in nature. The electrophile causing this substitution is sulfur trioxide, that is SO3, which is generated by the reaction between the two sulfuric acid molecules.
Let us now discuss mechanism of sulphonation of benzene. Sulphonation of benzene is carried out by either concentrated sulfuric acid or by fuming sulfuric acid. The reaction proceeds as shown on the screen. Let us first discuss step 1, which is the generation of electrophile. In this case, the electrophile is sulfur trioxide. The electrophile in this case is neutral but electron deficient since the oxygen is more electronegative than sulfur. It is formed as shown on the screen. We will now discuss about step 2, which is attack of electrophile on the ring. The electrophile attacks the ring to form carbocation intermediate which gets resonance stabilized. We will now discuss the third step. The hybrid loses hydrogen ion to HSO4 negative ion in a fast step to form the desired product. Under acidic conditions and in presence of water, benzene sulphonic acid is formed.
We will now learn about Friedel-Crafts reaction. Benzene is known to react with alkyl halides and acid chloride or acid anhydride in the presence of anhydrous aluminum chloride to form alkyl benzene or aromatic ketones. Friedel-Crafts alkylation. The reaction intermediate in this reaction is a carbocation which is generated by the reaction between the alkyl halide, that is RCl, and anhydrous aluminum chloride, that is AlCl3.
Children, let us now learn about mechanism of alkylation of benzene by Friedel-Crafts reaction. Alkylation of benzene is carried by alkyl halide in the presence of anhydrous aluminum chloride, which is a Lewis acid. It is illustrated with methyl chloride and proceeds as we will learn now. Let us discuss the first step now. Generation of electrophile, that is methyl ion. The Lewis acid catalyst obtained from anhydrous aluminum chloride helps in generating the electrophile as shown on the screen. Let us now discuss the second step, which is attack of electrophile on the ring. The electrophile, which is methyl group, attacks the ring in a slow step to form carbocation which gets resonance stabilized. We will now discuss the third step, that is abstraction of hydrogen ion by the nucleophile. The hybrid loses a hydrogen ion to AlCl4 negative which acts as a nucleophile in a fast step. Products formed are toluene, aluminum chloride and hydrogen chloride. We will next learn about Friedel-Crafts acylation. Aromatic ketones are obtained when benzene is treated with acid chloride or acid anhydride in the presence of anhydrous aluminum chloride.
विद्यार्थियों, ਹੁਣ oxidation of benzene बारे पढ़िए. Benzene can be oxidized by number of different reagents. The nature of the product obtained depends upon the nature of oxidizing agent used in the reaction. Let us first learn about catalytic air oxidation, in which oxidation of benzene by air in the presence of vanadium pentoxide can be carried out in different ways. Let us have a look at the first one, that is at 300 degree. Phenol is obtained as the major product. At 450 degree, maleic anhydride is obtained as the major product along with carbon dioxide and water. ਹੁਣ ਅੱਗੇ ਅਸੀਂ silver oxide oxidation ਬਾਰੇ ਜਾਣਾਂਗੇ. Silver oxide oxidation. In this kind of oxidation, mainly para-benzoquinone is formed when oxidation of benzene is carried out by silver oxide and nitric acid. Benzene reacts with nascent oxygen in presence of silver oxide and nitric acid to form para-benzoquinone. ਹੁਣ ਅੱਗੇ ਅਸੀਂ combustion of benzene ਬਾਰੇ ਪੜ੍ਹਾਂਗੇ. Combustion of benzene. In the presence of excess of air, benzene on heating oxidizes to carbon dioxide and water. Due to high carbon content in benzene, it burns with a smoky flame. Ozonolysis of benzene. Benzene forms 3 molecules of glyoxyl, that is ethane 1,2-diol, on oxidation in the presence of ozone, that is O3. विद्यार्थियों, आओ हुण disubstitution of benzene बारे पढ़िए. In disubstitution of benzene, 3 different isomeric products are possible, corresponding to ortho, meta, and para positions. The nature of the product obtained depends upon the directive influence of the group already present over the benzene ring. Various groups over the ring can be classified in 2 categories as activating or ortho-para directing groups and deactivating or meta directing groups. आओ हुण इन्हां बारे एक करके विस्तार विच जाणीए. Activating or ortho-para directing groups. These are the groups which are having either plus I or plus M effect over the ring. These increase electron density over the ring and hence its reactivity towards electrophilic substitution. These direct the attack of electrophile over ortho and para positions. For example, the groups shown on the screen. Let us now learn about deactivating or meta-directing groups. These are the groups having minus I or minus M effect over the ring. This decreases electron density over the ring and hence its reactivity towards electrophilic substitution. These direct the attack of electrophile over meta position of the ring. Few examples of these are shown on the screen. For the brief review of chemical properties, look at the chart given on the screen. ਹੁਣ ਅਸੀਂ ਅੱਜ ਦੇ ਪਾਠ ਵਿੱਚ ਕਾਫੀ ਕੁਝ ਜਾਣ ਗਏ ਹਾਂ. ਹੁਣ ਅਸੀਂ ਅੱਜ ਦੇ ਇਸ ਵਿਸ਼ੇ ਚੋਂ ਬੈਂਜ਼ੀਨ ਤੇ ਆਧਾਰਿਤ ਕੁਝ ਸਵਾਲ ਪੁੱਛ ਕੇ ਇਹ ਪਤਾ ਕਰਦੇ ਹਾਂ ਕਿ ਤੁਸੀਂ ਅੱਜ ਦੇ ਇਸ ਪਾਠ ਵਿੱਚੋਂ ਕੀ ਸਿੱਖਿਆ ਹੈ. My question for you is, benzene undergoes substitution reaction more easily than addition because it has cyclic structure, it has 3 double bonds, it has 6 hydrogen atoms, because of resonance. And the correct answer is because of resonance. If there were no resonance in benzene, p electrons would have not been delocalized and hence easily available to undergo addition reactions as in ethylene. Next question is, which of the following reagents and conditions convert benzene to chlorobenzene? Chlorine, sunlight, heat, hydrochloric acid, heat, hydrochloric acid, sunlight, heat, chlorine, aluminium, chloride, cold. And the correct answer is chlorine, aluminium chloride, cold. This is because chlorination of benzene is carried out by chlorine in presence of halogen carrier like aluminium chloride. Next question. Benzene reacts with n-propyl chloride in the presence of anhydrous aluminium chloride to give predominantly n-propyl benzene, isopropyl benzene, 3-propyl-1-chlorobenzene, no reaction. The correct answer is isopropyl benzene. What do you think is the reason for this? Propyl carbonium ion is primary carbonium ion. It rearranges to the more stable secondary carbonium ion by 1,2 hydride shift, which then reacts to form isopropyl benzene. ਬੱਚਿਓ, ਮੈਨੂੰ ਉਮੀਦ ਹੈ ਕਿ ਤੁਹਾਨੂੰ ਅੱਜ ਦਾ ਇਹ ਪਾਠ ਕਾਫੀ ਦਿਲਚਸਪ ਲੱਗਿਆ ਹੋਵੇਗਾ। ਥੈਂਕ ਯੂ ਫॉर योर ਅਟੈਂਸ਼ਨ। ਅਗਲੀ ਵਾਰ ਇੱਕ ਹੋਰ ਨਵੇਂ ਵਿਸ਼ੇ ਦੇ ਨਾਲ ਮਿਲਾਂਗੇ। ਤਦ ਤੱਕ ਲਈ ਇਜਾਜ਼ਤ।